Hello and welcome. So we're going back to financial modeling school next week. I'm going to start the 2014 model off questions, but just a little bit of weekend fun before we do. I'm going to be playing with the spelling bee today. If you haven't come across it, this is I think a New York Times game, or I'm sure you can find it a bunch of other places as well. The idea is you've got 7 letters in a little kind of beehive, and you have to make as many words as you can from those 7 letters. The rules are your word has to contain the gold letter in the center, and it has to have at least 4 letters. And aside from that, you can use letters more than once. So here, for example, you could do the word popular with 2 P's. That's no problem. But you couldn't do the word rap, for example, R-A-P, both because it's not long enough and because it doesn't contain the middle letter. The middle letter is the one I most often trip up on. So obviously, if you do the spelling bee because it brings you joy and relaxation, then don't build an Excel spreadsheet to solve the spelling bee for you. Personally, although I'm into all kinds of puzzles and games, I don't find the spelling bee brings me any joy or relaxation. So for me, it's just an interesting Excel puzzle. But anyway, so that's kind of general context. I guess the other thing to mention is, there are sort of grades as you go along. So there's sort of beginner, good start, moving up, blah blah blah, all the way up to genius. And depending on how many words are available to be found on any given day, it'll tell you how many points you need to get to this. And the way the points work is you get 1 point for a 4-letter word, and then for any longer word, you get the number of letters in the word is your points. So if you get an 8-letter word, you get 8 points. If you get a 5-letter word, you get 5 points. 4-letter words are only worth 1 point. And if you come up with a word that uses all 7 distinct letters, it's called a pangram, then you get an extra 7 points for that as well. So if we want to spoil all the fun and solve this puzzle in Excel, how would we go about doing it? Well, first, we're going to need to start with a list of possible words. And my inclination is to start with kind of the biggest list we can. So what I have here is the Saupods Scrabble list, which is 268,000-ish words. And as you can see, there's lots of like weird stuff in here, like "ing" and "ahs," and I have no idea what "al" or "ali" or any of this stuff is. But anyway, it's the whole point is to kind of cast a broad net. I will say I know the list for spelling bee is kind of manually curated with the intention of kind of removing words that are obscure or weird or technical or whatever. So this is going to be too big a set, but you'll see that's kind of easier to work with than the other. So the first thing I'm going to do, just to, because 270 odd thousand rows of data is a lot, we can kind of save ourselves a little bit of calculation time later by just trimming this down to ones that are possible spelling bee words. So the first thing we can do is just filter this where the length is at least 4. So the length of that is greater than or equal to 4, which, doesn't, as a proportion of all the words in there, doesn't cut out a lot. But if you asked me how many 2- and 3-letter words I could think of, I certainly would not come up with 1,416, which is what we've filtered out. But anyway, that's the first thing. And then the second thing is any word that has more than 7 distinct letters can never be the solution to a spelling bee, and that's actually going to take out a bunch more. So how are we going to check on that? Well, there's two ways you might think about doing it. One is if you sort of lay out all the letters in a word. So we can do that with mid. So let's say this is a 5-letter word. So if we take the mid, just takes a cut of letters from a word. So we're going to take the string starting at positions 1, 2, 3, 4, and 5, and of length 1, which means in this case just all the letters of the word. And then you can use unique to dedupe that and then figure out how many letters are in there. So what would that look like? You could say rows or count. Either one works the same. Of unique, of mid, of this sequence, the length of the word, comma 1. Yeah, you bet it's going to affect a large number of cells. Anyway, we won't labor the point. But so here, for example, you can see Ardwolves has more than 7 distinct letters. abactinally, whatever the heck that means, abacterial, and so on, have more than that number of unique words. So how would we filter that? Well, you can use, I mean, you could just fill in every cell like this and then filter like that. But if you want to be Swish and modern, and part of the reason I'm showing you this is because it's a good way to showcase some of the Swish modern functions, then you can say map. Map is just basically a way of applying some function to every item in a list. It's a little bit more to it than that, but so what is that function? Well, we got to use the language of lambdas to write a new function. So what we want is the function that takes a word and returns the number of unique letters in that word. So what is that function? Well, it's a function that takes one argument, we'll call it word, and returns the exact same as we had before, rows of unique, of mid, of word, sequence, len of word, one, and then we just close out all the brackets. That's the end of the map. And then what we're interested in is this map being less than or equal to 7. And we filter that, and we should end up with, so we get just under 146,000 words. So that actually knocks out about 120,000 words. So that does shorten the list a decent amount. So anyway, that's just set up. So I'm going to shut that down because I have a file over here that has the kind of pre-trimmed word list in it. And so the idea is we're going to put an input in here where, again, remember that the first letter is treated differently. So we're going to put the first letter first. I'm recording this on Thursday, so this is Thursday's spelling bee. Obviously won't put it up today because no spoilers. But so we're going to put the first letter first, that's the middle letter, and then all the others can be in whatever order you want. And the aim is to have something that tells us all the words that match, something that tells us the pangrams, and then I'll tell you what's going on over here later. So let's do the pangrams first, actually, because they're the easier piece. So if you just think about the logic, for a pangram, it has to contain all 7 of these letters. And because we've already filtered it down to 2 words with no more than 7 unique letters, if it does contain these 7 letters, then it doesn't contain any other letters. So that's actually enough. So you could say filter, just name this dictionary, where, so you want to say, just first of all, does it contain an I? Then you could say is number search I in dictionary. And basically what that gives you is when you search for I, if it finds it somewhere, like let's say the 3rd letter is I, it returns a 3. If the 7th letter is I, it returns a 7. If the letter I is not in there anywhere, then it returns an error. And then is number just gives you true if it's any number, meaning that I is in there in any position, and false if it returns an error, meaning I is not in there anywhere. So you can do that, and then you can do basically the same thing on here. And then now we're searching for the letter D. And you can kind of carry on across in that way. Now we're searching for M. Now we're searching for A. Now we're searching for E. Now we're searching for Y. And now we're searching for T. And sure enough, you gradually whittle it down. There's only one pangram today. Sometimes there's more than one. I think there always is one. But so we've got one pangram, which is daytime. Now, how can we make this process more efficient? Well, there's the handy-dandy function for that called reduce. And reduce basically applies some function to, you basically have, think of it as like a running total or a running kind of interim step. It applies some function to your interim step and a new input for every item in a list of inputs. So in this case, what we want to do is filter for contains this letter for each of the 7 letters in here. So what's that going to look like? It's going to look like this. So reduce, we want to start with dictionary, and we want to reduce it for each of the 7 letters in here. So again, we'll say mid this sequence. I mean, it's always going to be a 7 for spelling bee, so I'll just hard code it. or if you want to be particular, you could say length of that. And then the function that you're going to apply at each step. So again, it is the function that takes two arguments. So again, in lambda terms, that's just lambda, two variables. So a, think of it as what's sort of accumulated, and v is the new value. So a will start off as this, and v will start off as the first one of these, which is I. And then a will become the output of that function, and v will become the second one of these, and then a will become the output of that function, and v will become the third one of these, and so on. So at each stage, what we want to do is filter a where a contains, where the words in a contain v. So that's going to be the same as before, is number search for v within a. Close lambda, close the reduce. That's it. Okay, so now all words is going to be a little more complicated than that. I'm going to show you two ways that you might do it. They both kind of hinge on using reduce. So basically, think about the logic. What words in here can be made from these letters? There's two ways you can do it. You can either say, if I take out all these 7 letters from here, there's nothing left. In other words, it only contains these 7 letters. Or you can say, it does not contain any of the other 19 letters that are not in here. Okay, and each one of those you can use to make a formula. So let's just do a little setup first. So we're going to say input is this word here, and I'm using let as a kind of nice way to just lay out all the steps. So that's the input. We've got the dictionary. So I'm going to say start is, because it has to contain, remember, the first letter. The first letter is different from the others. So filter dictionary where is number search left input. You can say left input 1, but default is 1. So search for that in dictionary, close search, close is number, close filter. So that's start. Then we want, I'm just going to get my spacing here. Then we want final is going to be, so first I'll do the one where we just take out any of the other 26 letters. So we're going to say reduce start by, now what I want here is the steps of reduce are going to be the 26 letters of the alphabet. So one way to do that is char of sequence, 26 letters, and you can, well, you need to do this. Where do you start? Where's the first letter of the alphabet? Code of A. So char and code are basically switching between Unicode characters and Unicode codes. So it's just a way of basically being able to generate text using the sequence function. So the Unicode code for A, you can see it up here, is 65. And so I'm going to have 26 numbers starting from 65 and turn those into characters. And if I highlight that, you can see that gives me A, B, C, up to X, Y, and Z/Z. Controversial question, depending on what side of the Atlantic you're on. So then what are we going to do? Again, you know, A is what we've accumulated, V is the new value. So we're going to say if, so first thing is if the letter is one of these 7, then I don't want to do anything. So I want to say if is number search V in input, then return A. Otherwise, we're going to filter, I'll just bring the lambda down onto a new line to make this a little easier to read. We're going to filter A where, and this time we want to say where we do not find the letter. In other words, it's a letter that's not in the input, so it should not be in the word. So we're going to say is error, not is error, is error, search for V in A. Closes the filter, that closes the if, that closes the lambda, that closes the reduce. So just pull it back in a little, and then we can just drop out final, and then we'll take another look. So that gives you the full list. So there are 125 possible matches in the dictionary for this. And then what we might want to do is, if you're thinking about kind of entering these in, then you might be more interested in sorting by higher scoring ones. So we could say sort by final, len final, -1. In other words, sort that in descending order by length. And as you can see, there's lots of like, demediated, I have no idea what that is, demediate, immediate, there's a real word, meditated, admitted, admittee, and so on. So I've kind of done this a few times. My usual heuristic is if it looks like a word to me, then it probably is an acceptable word to spelling bee, and I just put it in. And if I look at it and say I have no idea what that word is, then I just skip over it, and that usually gets me pretty close to the mark. So I played it today. I'm already at genius, but there is a secret top level which they don't show on the chart here, which is called Queen Bee. And if you can find every single one of the words in a particular hive, then you get to be Queen Bee for the day. So if you want to really take this, to the extreme, you could try, typing in every single one of these. There are 125 of them versus, I found 59 matching words, so it's like 2x. It could be worse. But I have no desire to kind of sit and type all these words in. So what's the alternative? Well, you can look at the hints. So every day they give you a hint grid. So it tells you, these are today's letters. There are 60 words in total, 269 points. There's one pangram. I'll explain perfect and bingo in a minute. And then it tells you this is the distribution. So, there are 7 words starting with A, 2 of length 4, 4 of length 5, 1 of length 8. There are 13 words starting with D, 3 of length 4, 3 of length 5, 5 of length 6, 1 7, 1 8, and so on. And then it also gives you this 2-letter list. So you can see there are, these are all the, for the words that start with A, there are 2 that start with AD, 3 that start with AI, 2 that start with AM. And then same thing for the ones starting with D, starting with E, I, M, T, and Y. And so in theory, you could, go and look through your list here very carefully, compare it to what's over here, and figure out where your gaps are. But again, if you're here more for the fun of the Excel puzzle than the spelling bee solving itself, then you might want to try something else, which is what I tried. So I've basically built this hint helper page. I'm not going to rebuild this one from scratch because it will probably be a little bit tedious to watch. But the idea is that you come over here, you copy, sorry, let me scroll down, scroll across, you copy your list of words, paste it in here, and then this, through some jazzy formulas, reproduces this grid, except it's based on the answers that you actually have, rather than on the total set of answers available. But the idea is then you can compare very easily. You can say, okay, I have 7 A's. The hint says there should be 7 A's, so I've got all the A's. There should be 13 D's. I have 12 D's. Okay, so I'm missing a D. And actually, in this case, I've already got 59 out of 60 words, so I know that the D is the only thing I'm missing. And then I can read across here and say, okay, I've got 33411, 33511, so I'm missing a 6-letter D. And then I can look down here to say, well, I've got 237, I should have 238. So I'm missing a 6-letter D starting with DI, and that is what this little piece over here is. So the idea is you put in, what does it start with, what's the length, and then we'll just filter this, where length of this is equal to length times left of this 2 equals, or actually, let's not make it 2, let's make it length of this, because then we could have, if we weren't sure which 2-letter pair it started with, which we might not be, then we could just do that. So left of that, length of that is equal to this. And that tells me these are the possible 6-letter DIs. So we've got diadem, dieted, and dimmed already in there, because I did look at this before I put the video on. I haven't figured out which of these it actually is. I don't know any of these words, but I'm gonna try and get queen bee live in the video just for fun. I think it's dimity. I've never heard of it, but you know, I put some of these into Google or Bing or whatever. You know, this one, it's like, okay, yeah, there's a dictionary definition here. There's a nice little Wikipedia article here. Some of these others, like I put in did it, and it was like, you sure you meant did it? All right, yeah, no, I really meant did it. Still not sure. Maybe that's a company, maybe something else. Bit messy. So just on the random Google metric of obscurity, I'm guessing the answer is dimity, but let's put it in and hopefully, yes, Queen Bee, you found everything. So there you go. Hooray. That's kind of the end, but if you want to, I will give you a quick tour of how these three are put together. So we can just add in dimity so that we fully reproduce. So we got 60, 269 points, 1 pangram, 1 perfect, bingo. So what is going on over here? Well, the word count is pretty straightforward. The points I've explained. Pangrams, fine. The perfect, I had to go and search the spelling bee glossary for that. A perfect pangram is one that uses all 7 letters and uses them exactly once each. And then bingo means there's at least one word, yes, at least one word starting with all 7 letters. So, you know, for some hives, you don't get, there might only be words starting with 3 or 4 or 5 or 6 of the letters. In this case, it's a bingo because there are words starting with all 7 letters, although there's only one for Y. So how does the formula go? Well, here's what it looks like. So the whole thing is wrapped in an if error, enter some words to start, because these things all error out when there's no words there. So if it's an error, then enter some words to start. Then, so the idea is you can kind of drop your words anywhere in column A, and we've no idea how big that's going to get because there could be lots of words. So we start off with just saying, define the list of words as filter column A, where column A is not blank. Then we're going to get the list of pangrams. So again, same idea as we used before. So take the list of words and map against that using the function that takes a word and returns the number of unique letters in that word. And we're going to filter for that is equal to 7. So in other words, 7 unique letters in the word. And the optional third argument for filter is what do you give if it's empty? So we just said give none if it's empty. And then we construct the output to match the way it looks on the hint page. So, the word words followed by the number of words, the word points followed by the number of points, the word pangrams followed by the number of pangrams, the number of perfect pangrams in brackets, and then bingo if it's a bingo. So what does that look like? Well, words is just the rows of words. Points is sum of if the length is 4 then 1, otherwise the length, plus the bonus for pangrams. So 7 times if your pangram is none, 0, otherwise the number of rows in your list of pangrams, because you get a plus 7 for each of those. Then how many pangrams? So again, if the list of pangrams is none, then 0, otherwise the number of rows in that. And here we're just checking how many of those have length 7. And we don't have to check for none there because none does not have length 7, so that won't give any. So that's how many are perfect. And then if rows unique left words, so in other words, so left of words is all the starting letters, unique of that is the unique list of starting letters, and rows of that is how many rows of that are there. If there are 7 rows, in other words, if there are 7 unique starting letters, then it's a bingo. So that's that one. This one gets even bigger, but let's take a quick look. So again, the word list we just defined as before. The list of first letters, so that's basically going to be this column here. So that's sort unique left words. So in other words, all the first letters that appear, only the unique ones, and sorted A to Z because that's the way they appear here. Then the lengths is again just the list of unique lengths. I did kind of notice this at some point before that there are cases where, let's say, there are words of length 4, 5, 6, 7, 8, and then 10. So it does skip over if there are blanks. So I made my logic mirror that. So again, you take the length of the words, you take the unique of that to get the unique list of word lengths, you sort that, and then transpose, that's going to lay out across the top. And then the counts. This is where, my ongoing, please, 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 Microsoft, make countifs able to accept a dynamic array input, but right now it's not able to. If it was, then we could just say, count ifs the list of words where, the length is this and the thing is that. But anyway, we can't. So so what do? We do make array. So make array just says make an array with, this many columns and this many rows, and use a formula, again, use a function, meaning a lambda, to define what goes in based on the row number and column number. So lambda of row and column. So in this case, the number of rows, I'm basically generating now this block here. Escape so I don't break that. So the number of rows is the number of rows in your list of unique first letters, and the number of columns is the number of columns in your list of unique lengths. And then for each intersection, we're saying the word starts with the rth letter from the list, and the length of the word is the cth letter, c being the column number. So that generates this thing, and then the output is, H stack. So we basically make 3 blocks and stack them side by side, and then each block is a V stack. So the V stack is a blank for this top left cell, then the first letter is followed by a colon, again, because I'm just being pedantic, matching the format here exactly, and then a big sigma for a sum with a colon. Then the second block is the lengths over the counts. So the lengths is this top header row, the counts is here, and then the sum of the rows, you can just use a BYCOL, so BYCOL on the counts. So for each column, use the function that takes x and returns the sum of x, and apply that to each column. So in other words, sum of this column to get the 22, sum of this column to get the 12, and so on across. And then for the last column, sigma in the top row, again, we're going to use a BYROW, which is exactly the same as the BYCOL, just sum up each row to get this. And then in the bottom right corner, it's just the sum of all the counts, which could equally just be the number of rows in your words. And then lastly, this one. So similar idea here, except here I did not filter the words because I want to be able to do a count ifs on it later. So again, we start by taking left of each word 2, in other words, all the 2-letter starting pairs, take the unique of those and sort them. That's your starting point. Then clean that, just filter out the blanks, because again, we haven't filtered our word list to drop all the blanks here, because I want to be able to do a count if on the word list in a minute. Then combo is basically each of these little blocks is one combo, so that's the uppercase version of clean, in other words, those starting 2 letters in uppercase, and a dash in between, and count ifs of word, clean, and star. So star here means any wildcard character. So in other words, it's how many words fit the pattern, these starting 2 letters plus any other letters that come after. In other words, how many words start with these 2 letters. Then we get the list of first letters. So we just take the first letter from each of the 2-letter pairs, unique those, and sort them. And then the output, we're going to map to each first letter the function that filter the combos. So remember, the combos is the DA-2, DE-3, DI-8, etc. Filter those where the first letter is equal to this first letter that we're mapping on, and then join them all together, text join, and then output that. So, like I said, don't let this spoil the joy in the game if you actually enjoy playing the game, but it's a nice way to get a little introduction to some of the things you can do with the kind of cool modern Lambda functions like reduce and map. BYROW, BYCOL are all in here. So I'll put the spreadsheet up online. Feel free to have a look. Oh, sorry, I just remembered that I said I was going to show you a second way to do this. So very quickly, I will do that. So another way to get all the words, so I mentioned the logic was you can either say it does not contain any of the 19 letters that it's not supposed to, or you can say that once you get rid of all the letters that it is supposed to contain, you've got nothing left. So how do we do that? So we're going to say from start, we're going to reduce. We've already filtered to must contain the first word, so we're just going to basically get rid of all 7 letters. So we're going to say mid of this, sorry, I have input because I've already named it. Sequence 7, 1. So that gives the 7 letters. Okay, it doesn't understand that because it doesn't understand that I've defined that name. So let's just select it here. So that's going to give those 7 letters, IDA, etc. And then what function are we going to apply? We're going to say lambda, again, AV. So A is what you've accumulated so far, V is the latest value, and it's going to be substitute AV blank. So in other words, replace V with blank in all the words in A. And then we're going to, so that'll give us either blank if it's a word that only contains these 7, or that doesn't contain any other letters than these 7, or non-blank if it doesn't. So then we're going to say filter on that start list where blank is equal to that. And hopefully, if I say and this equals this, it should say true. And it does. So that returns the same. So I'll just label this all words alt. All right, that's what I got for today. Like I said, back to financial modeling school with ModelOff next week, and have a good weekend.